Now the question is, let Sn be the sum of this series sin x plus sin 2x plus sin nx. Now basically angles are in AP with common difference of x. So what we'll do is we'll multiply and divide it with 2 sin x by 2. So it'll be this 2 sin x by 2 and then sin x plus sin 2x up to sin nx. Now we like this is 1 upon 2 sin x by 2 and will be 2 sin x by 2 into sin x, 2 sin x by 2 into sin 2x, 2 sin x by 2 into sin nx. Now will be 1 upon 2 sin x by 2. Now this is 2 sin A sin B. So it will be cos A minus B, which is cos x by 2 minus cos 3x by 2. Now here will be cos 3x by 2 minus cos pi x by 2. And in the end we'll have cos n minus 1 by 2x minus cos n plus 1 by 2x. Now all these terms, they'll cancel. So basically we'll get this Sn is 1 by 2 cot x by 2 minus cos n plus 1 by 2x upon sin x by 2. Now if we take this summation, r varies from 1 to n, SR will be this 1 by 2 n cot x by 2 and then minus this summation r varies from 1 to n cos r plus 1 by 2x upon sin x by 2. Now we need to find this limit n tends to infinite summation SR upon n. Now will be this limit n tends to infinite. Now here n and n will cancel. This 1 by 2 cot x by 2 and then minus this summation r varies from 1 to n cos r plus 1 by 2x upon sin x by 2. And the question it is given that x is unequal to 2k pi. That means this cos r plus 1 by 2 is not equal to 1. That means this cos r plus 1 by 2 is less than 1. So this summation, here we'll also have this n. This summation will be less than n, and in the denominator we have n. So value of this limit when n tends to infinite will be 0. So answer to this question will be simply 1 by 2 cot x by 2. Now in this question we given this f n theta and it is given as this product r varies from 1 to n 1 minus tan square theta upon 2 to the power r. Now what we'll do is we'll multiply and divide it with 2 tan theta upon 2 to the power r. So it will be this product r varies from 1 to n. Now this is tan 2 theta. So it will be this 1 upon tan 2 theta 2 to the power r, and this is 2 tan theta 2 to the power r, which is this product r varies from 1 to n 2 into 10 theta upon 2 to the power r upon 10 theta upon 2 to the power of r minus 1. Now we'll expand this product. Now we put r from 1 to n, it will be 2 into 2 into 2 n times. So that will be simply 2 to the power n. Now here if we put r as 1, it will be this 10 theta by 2 upon 10 theta. Now for r equals to, it will be 10 theta upon 2 square upon 10 theta upon 2, and we'll continue up to 10 theta upon 2 to the power n upon 10 theta and 2 to the power of n minus 1. Now terms cancel only after first one. So all these they will cancel. So we'll get this fn theta as 2 to the power n 10 theta upon 2 to the power n by 10 theta. Now we need to find this limit n tends to infinite fn theta. So this limit n tends to infinite fn theta will be this limit n tends to infinite, and we'll rearrange all this a bit. So we'll write this as 1 upon 10 theta. This is nothing to do with n, and it will be this 10 theta upon 2 to the power n, and we'll take this 2 to the power n in the denominator, so it will be 1 upon 2 to the power n. We'll multiply and divide everything with theta. Now when n tends to infinite, 1 upon 2 to the power n tends to 0. So this is 0 upon 0 form. So 10 0 upon 0 is 1. So answer to this limit is simply theta upon 10 theta. Now here the question is, we are given this function fnx, which is 10x by 2 into 1 plus secant x into 1 plus secant 2x up to 1 plus secant 2 to the power nx. Now what we'll do is, we'll write this 1 plus secant x as 1 plus cos x upon cos x, and everything else will remain the same. So it is 1 plus secant 2x up to 1 plus secant 2 to the power nx. Now we'll change it in terms of sine and cos. So it will be sine x by 2 upon cos x by 2, and 1 plus cos x will be 2 cos square x by 2 upon cos x, and this is 1 plus secant 2x up to 1 plus secant 2 to the power nx. Now here cos x by 2 will cancel. Now 2 sin x by 2 cos x by 2 is sin x. So we'll get this as 10x into 1 plus secant 2x 1 plus secant 4x up to 1 plus secant 2 to the power nx. Now here it was x by 2 and x, and here it is x and 2x. So situation is same. It is going to be 10 2x and then 1 plus secant 4x 1 plus secant 2 to the power nx. Again situation is same, so it will be 10 2 square x, and it will continue till the end where it is going to be 10 2n x. So this fnx is 10 2 to the power n into x. Now we need to find this limit x tends to 0 fnx upon 2x. So it will be this limit x tends to 0. Now fnx is 10 to the power nx, and here it is 2x. Now what we'll do is we'll multiply and divide it with 2 to the power of n minus 1. Now this becomes standard limit, which is 1. So answer to this limit is 2 to the power of n minus 1, and that's your option C. Now here the question is, we need to find the value of this limit. Limit n tends to infinite cos square pi, and this is n cube plus n square plus 2n to the power 1 by 3. Now we'll take n cube common, so it will be this limit n tends to infinite, cos square n pi, and here it will be 1 plus 1 by n plus 2 by n square to the power 1 by 3. Now what we'll do is we'll use binomial expansion. So we'll write this as limit n tends to infinite, cos square n pi, and here it will be 1 plus 1 by 3n plus 2 by 3n square plus higher power of 1 by n. Now we'll write this as limit n tends to infinite. Now this is cos square and n pi plus pi by 3 plus 2 pi by 3n. Now cos n pi plus theta is minus 1 to the power n cos theta. So it will be this limit n tends to infinite minus 1 square to the power n, and then cos square pi by 3 plus 2 pi by 3n. Now minus 1 square is plus 1, and if we take n tends to infinite, all these terms they will be 0. So this answer will be simply cos square pi by 3, and cos square pi by 3 is 1 by 4. And that's your option C. Now for this question, we are given this function f and x, which is this summation. J varies from 1 to n, tan inverse, and this is 1 plus x plus j into x plus j minus 1. And the numerator, we can write this one as x plus j minus x plus j minus 1 for all x belongs to 0 to infinite. Now this is tan inverse x minus y upon 1 plus xy, which is tan inverse x minus tan inverse y. So we'll write this f and x as this summation. J varies from 1 to n, tan inverse x plus j minus tan inverse x plus j minus 1. Now if we put j as 1, it will be this tan inverse x plus 1 minus tan inverse x, plus if we put j as 2, it will be tan inverse x plus 2 minus tan inverse x plus 1, and will continue up to tan inverse x plus n minus tan inverse x plus n minus 1. Now here in this case, tan inverse x plus 1 will cancel. So all these terms, they'll keep getting cancelled. So we'll have this term, and in the end we'll also have this term. So this f and x will actually be tan inverse x plus n minus tan inverse x, which we can also write as f and x, now tan inverse n upon 1 plus x square plus nx. Now in the first option it says fj0. Now 0 is not included in the domain, so that means we cannot define f0 or f-0. So option A and B, they are definitely incorrect. Now we need to look at this limit x tends to infinite, tan f and x. So it will be this tan, and then this limit x tends to infinite, and f and x is tan inverse n upon 1 plus x square plus nx. Now if x tends to infinite, it will be n upon infinite, which is 0, and tan inverse 0 is 0. So answer to this limit will be 0. That means this option C is also incorrect. Now if we look at this option D, then in that case it will be this secant square, and then this limit x tends to infinite, tan inverse n upon 1 plus x square plus nx, and we know that this limit is 0, so it will be this secant square 0, and secant square 0 is 1. So that means the only correct option is this option D. Now here the question is, for non-negative integers n, we are given this function fn in terms of summation and sign. Then we need to find which of the following options is or are correct. Now for this, what we'll do is we'll let pi upon n plus 2 as some constant, say theta. So we'll actually write this as Fn is this summation k varies from 0 to n sine k plus 1 theta into sine k plus 2 theta whole divided by this summation k varies from 0 to n sine square k plus 1 theta. Now we'll multiply and divide it with 2. Now this is 2 sin A sin B, and we know that 2 sin A sin B is cos A minus B minus cos A plus B. So it will be this summation k varies from 0 to n and cos A minus B. So it will be k plus 2 theta minus k plus 1 theta. It will be simply cos theta minus this summation k varies from 0 to n, and it will be cos A plus B, and that will be 2k plus 3 into theta, and the denominator will be this summation k varies from 0 to n and 1 minus cos 2 theta. So it will be cos 2 into k plus 1 theta. Now since theta is independent of k, this summation cos theta is summation of constant, so it will be this n plus 1 into cos theta. So we can write Fn as n plus 1 cos theta minus this summation k varies from 0 to n cos 2k plus 3 theta upon this summation 1 will also be n plus 1 minus this summation k varies from 0 to n cos 2 into k plus 1 theta. Now first we'll simplify these two summations. Now this first summation is summation k varies from 0 to n cos 2k plus 3 theta. Now if we put k as 0, so it will be this cos 3 theta, cos 5 theta, cos 7 theta up to cos 2n plus 3 theta, where angles are in AP. Now in this case, value of alpha is 3 theta and value of beta is 2 theta. That's your common difference. We know that sum of this series is sine n beta by 2. N beta by 2 will be number of terms is n plus 1 and beta by 2 is theta upon sine beta by 2, which is sine theta, into cos alpha plus, which is 3 theta plus n minus 1, which in this case is n, into beta by 2, which is theta. So it will be this sine n plus 1 theta into cos n plus 3 theta whole divided by sine theta. And if we look at this second series, which is this summation k varies from 0 to n cos 2k plus 1 theta, will be this cos 2 theta plus cos 4 theta. Now in this case, alpha equals beta equals 2 theta. Number of terms is n plus 1, and again angles are in AP. So we can write this as sine n beta by 2, so it will be this sine n plus 1 theta upon sine theta into cos a plus n minus 1 into theta. So it will be this sine n plus 1 theta into cos n plus 2 theta whole divided by sine theta. So now we have result for both the summations. So we can write this function fn as n plus 1 cos theta minus this sine n plus 1 theta cos n plus 3 theta upon sine theta divided by n plus 1 minus sine n plus 1 theta into cos n plus 2 theta upon sine theta. Now we have taken pi upon n plus 2 as theta, so we can write n plus 1 theta as pi minus theta. So sine n plus 1 theta will be sine theta and n plus 2 theta will be simply pi. So sine n plus 1 theta and sine theta will cancel, and here we'll get this as n plus 1 cos theta minus cos. Now n plus 2 theta is pi, so it will be this pi plus theta, and here will be this n plus 1 minus cos pi. Now cos pi plus theta is minus cos theta, so here will be this minus minus plus, so we can write this as cos theta into n plus 2 upon n plus 2, and will also cancel. So basically this function fn will be cos pi upon n plus 2. So now we have our function fn, which is cos pi upon n plus 2. Now the first part is f4. Now this f4 is cos pi by 6, and cos pi by 6 is root 3 by 2. That means option A is correct. Now f6 will be cos pi by 8. Alpha is tan of cos inverse f6, and cos inverse f6 is pi by 8. So it will be this tan pi by 8, and tan pi by 8 is simply root 2 minus 1. Now we take this one on the left hand side in square, we get alpha square plus 1 plus 2 alpha will be equal to 2, or alpha square plus 2 alpha minus 1 equals 0. That means this option B is also correct. Now for this C, we need to find f5. f5 is cos pi by 7. Now sine 7 cos inverse f5 will be sine 7 pi, and sine 7 pi is 0. That means option C is also correct. And then this limit n tends to infinite, fn will be this limit n tends to infinite cos pi upon n plus 2. Now this is cos 0, and cos 0 is 1. So option D is incorrect. So the correct options are A, B and C. Now here the question is, we are given the series Sn, which is this summation R varies from 1 to n, and this is tan inverse. Now we divide everything with 4, we can write this as 2r minus 1 by 2 upon 1 minus r square and r minus 1 whole square by 4. Now we can simplify this as this summation R varies from 1 to n, and will be this tan inverse r by root 2 square minus r minus 1 by root 2 square, and here it will be 1 plus r by root 2 square and r minus 1 by root 2 whole square. Now this is tan inverse x minus y upon 1 plus xy. So we can write this as this summation r varies from 1 to n tan inverse r by root 2 square minus tan inverse r minus 1 by root 2 square. Now if we put the value of r, we can write this as tan inverse 1 by root 2 minus tan inverse 0 plus tan inverse 2 by root 2 square minus tan inverse 1 by root 2 square, and in the end we'll have tan inverse n by root 2 square minus tan inverse n minus 1 by root 2 whole square. Now here all these terms they'll cancel. So basically we'll get this Sn as tan inverse n square by 2. Now we need to find this limit n tends to infinite. This summation n varies from 2 to n cot Sn minus 1 minus cot Sn. Tan inverse n square by 2 is cot inverse 2 by n. So we can write this as limit n tends to infinite, and then this summation n varies from 2 to n, and here it will be 2 upon n minus 1 square, and this one is going to be 2 upon n square. Now if we put the value, we can write this as 1 upon 1 square minus 1 upon 2 square, 1 upon 2 square minus 1 upon 3 square up to, now all these terms they'll cancel. So this sum s dash n will be given by 2 into 1 minus 1 n square. Now we need to find this limit n tends to infinite. Now we take this limit n tends to infinite. Now this is just 2. So answer to this question is simply 2. Now here the question is we need to find the value of this limit. Now this is limit x tends to pi by 2, that is 4 root 2 sin 3x plus sin x whole divided by 2 sin 2x into sin 3x by 2, and what we'll do is we'll take these two together. So we'll write this as cos 5x by 2 minus cos 3x by 2, and then minus we'll take root 2 common, and it will be 1 plus cos 2x. Now we'll use trigonometric formulas. So we'll write this as limit x tends to pi by 2. Now this is 4 root 2. Now sin c plus sin d is 2 sin c plus d by 2. So it will be 2 sin 2x into cos c minus d by 2. So it will be into cos x. In the denominator we have this 2 sin 2x into sin 3x by 2. Now this is cos c minus cos d. So it will be 2 sin c plus d by 2, and there will be 8x upon 4. So it will be this sin 2x and then sin d minus c by 2. So there will be sin x by 2 with a minus sign, and here will be this root 2, and this is 2 cos square x. Now here what we'll do is we'll take 2 sin 2x common. So we'll write this as limit x tends to pi by 2, and this is 8 root 2 sin 2x into cos x, and here if we take 2 sin 2x common, we are left with sin 3x by 2 minus sin x by 2. Now sin c minus sin d is 2 sin c minus d by 2, which is sin x by 2 into cos c plus d by 2, which is cos x minus 2 root 2 cos square x. Now since limit as x tends to pi by 2, we have problem with cos x. So what we'll do is we write sin 2x as 2 sin x into cos x. So now we'll write this limit as this limit x tends to pi by 2, and this is 16 root 2 sin x into cos square x, and here it will be 8 sin x into sin x by 2 into cos square x minus 2 root 2 cos square x. Now cos square x will cancel. If we put this limit, we'll get this as 16 root 2 upon, now this is 8 and sin pi by 2, and sin pi by 2 is 1 and sin pi by 4 is 1 by root 2 minus 2 root 2. So it is 16 root 2 upon 2 root 2, which is 8. So answer to this question is 8. Now here the question is, for any positive integer n, let Sn be defined as this summation k varies from 1 to n cot inverse of 1 plus k into k plus 1 x square upon x, and we'll write this x as k plus 1x minus kx. Now if we take its reciprocal, we can write it in terms of tan inverse, and it is tan inverse x minus tan inverse y. If we take its reciprocal, then we can write it in terms of tan inverse, and we know that tan inverse x minus y upon 1 plus xy, it is tan inverse k plus 1x minus tan inverse of kx. Now we'll simplify this summation. When k is 1, it will be tan inverse 2x minus tan inverse x plus tan inverse 3x minus tan inverse 2x, and we continue up to tan inverse n plus 1x minus tan inverse of nx. Now these terms, they'll cancel. Now since this second one here, in the end, it will be this term. So we can write this Sn as tan inverse n plus 1x minus tan inverse of x, or we can write this as tan inverse nx upon 1 plus n plus 1 into x square. So that's a function Snx. Now domain of this function is from 0 to infinite to r. Now in this first option it says S tan x. Now for S tan x we'll put n as 10. So it will be this tan inverse of tan x upon 1 plus 11x square. Now we can write this as cot inverse of 1 plus 11x square upon tan x, and we know that cot inverse x is pi by 2 minus tan inverse x. So it will be pi by 2 minus tan inverse 1 plus 11x square upon tan x. That means this option A, it is correct. Now for this option B, we need to take this limit n tends to infinite cot, and then it will be this tan inverse. And since it is infinite limit, we look at highest power of n. In the numerator it is 1. In the denominator also it is 1. So answer to this question will be coefficients of n. So coefficient of n in the numerator is x, and in the denominator is x square. Now we know that tan inverse 1 by x is cot inverse x, and cot of cot inverse x is x. So this value will be x. Now for this C it says S3x equals pi by 4. Now what is S3x? It will be tan inverse of 3x upon 1 plus 4x square, and we put it equals to pi by 4. Now we can write this equation as 4x square minus 3x plus 1 equals 0. Now discriminant for this quadratic equation is 9 minus 16, which is less than 0. So this equation will have no real root. So C is incorrect. Now in part D it says tan of S and X is always less than equal to 1 by 2 for any n greater than equal to 1 and x greater than 0. Now what we'll do is we'll take this as some function y, and this y will be nx upon 1 plus n plus 1 x square. Now we'll find its absolute maxima and minima when x is greater than 0. Now we find dy by dx. dy by dx will be 1 plus n plus 1 x square into n minus nx into n plus 1 into 2x upon 1 plus n plus 1x whole square. Now here we'll take this n common, then we can write 1 plus n plus 1 x square, and here will be minus 2 n plus 1 x square upon 1 plus n plus 1x whole square. Now we solve this, we'll get two critical points, plus or minus 1 upon under root of n plus 1. Now it will be minus 1 upon under root n plus 1 and plus 1 upon under root of n plus 1. Now we do not know anything when x is less than 0. So we are just concerned with this point. Now rightmost it is minus and then it is plus. So we'll have a local maxima when x is 1 upon under root of n plus 1. So this maximum value of y, it will be n upon under root of n plus 1 and 1 plus n plus 1, 1 upon n plus 1, so it will cancel. So it will be this n upon 2 under root of n plus 1. Now it is always greater than n upon twice under root n, and we can write it is greater than under root n by 2. Now since n is greater than 1, then this value is greater than 1 by 2. So its maximum value is actually greater than 1 by 2. That means this option D is incorrect. So the correct options are only A and B. Now here the question is, we need to find the value of this limit, which is limit n tends to infinite cos x by 2 into cos x by 2 square up to cos x by 2 to the power n. Now what we'll do is we'll multiply and divide everything with 2 to the power n sine x upon 2 to the power n. So it will be this 2 to the power n sine x upon 2 to the power n. Now we take 2 sine x upon 2 to the power n into cos x upon 2 to the power n. This is 2 sine theta cos theta, which is sine x upon 2 to the power n minus 1. So what will happen is we'll keep getting this formula for sine 2x, which in the end will be 2 cos x by 2 and sine x by 2, which is nothing but limit n tends to infinite sine x upon 2 to the power n sine x upon 2 to the power n. Now this is n tends to infinite, so 2 to the power infinite is infinite, so this is infinity into 0 form. So what we'll do is we'll write it in standard limit, so it will be this limit n tends to infinite, and this is sine x, and we'll write this as sine x upon 2 to the power n divided by 1 upon 2 to the power n. Now we'll multiply and divide it with x. Now this is sine 0 upon 0, which is indeterminate form whose limit is 1. So answer to this limit is simply sine x upon x, and that's your option B. Now here the question is, we need to find this limit x tends to infinite cos 2 pi x upon 1 plus x to the power a whole to the power x square if a belongs to R. Now first we'll check its form. Now this is x upon 1 plus x. When x tends to infinite, it will be 1. Now cos 2 pi is 1, and 1 to the power x square is 1 to the power infinite. So it is 1 to the power infinite form. That means we are going to use this shortcut directly. So it will be this e to the power, and then this limit x tends to infinite x square into cos 2 pi. Now we'll actually write this as 1 plus 1 upon x to the power minus a and then minus 1. Now here we'll use binomial expansion of 1 plus x to the power minus n. So it will be this e and then this limit x tends to infinite and then x square, and we can write this as cos 2 pi 1 minus a upon x, and then it will be minus a minus 1. So it will be this a into a plus 1 upon 2 1 by x square and plus higher power of x and then minus 1. Now cos 2 pi minus theta is cos theta. So we can write this as e to the power limit x tends to infinite, and we'll take minus common. So it will be this x square 1 minus cos 2 pi a upon x plus other terms. Now we'll rewrite this as e to the power limit x tends to infinite minus x square 1 minus cos 2 pi a upon x. Now we'll multiply and divide everything with 4 pi square and then a upon x whole square. Now we have to multiply it also. Then will be this 4 pi square a upon x whole square. Now this becomes a standard limit which is 1 by 2. So we can write this as e to the power and then this limit x tends to infinite minus 1 by 2 into x square into 4 pi square a upon x a plus 1 upon x square whole square. Now we multiply this x square, we'll get this a square. So it will be this e to the power minus 2 pi square into a square, and that is the answer to this limit. Now here the question is, a circular arc of radius 1 subtends an angle of x radian. As shown in this figure, point C is intersection of two tangent lines at A and B. Let Tx be the area of triangle ABC and Sx be the area of shaded region. Then we have to find Tx, Sx and this limit. Now radius is 1. If we draw a line here, this angle will be x by 2 and this is 90. And suppose this point is D. So this is A, B, C, and we have this triangle ABC. Now in this triangle OBD, we can write BD as 1 sine x by 2. That means value of AB is 2 sine x by 2. And in this triangle, this angle is pi by 2 minus x by 2. So once we have BD, we can find CD. So we can write BD upon CD will be equal to 10 pi by 2 minus x by 2, which is cot x by 2. So we can write CD as sine square x by 2 upon cos x by 2. Now once we have AB and CD, we can write this Tx, which is area of triangle ABC. So this Tx will be 1 by 2 into 2 sin x by 2 into sin square x by 2 upon cos x by 2. I'll cancel. So we'll get this as sin cube x by 2 upon cos x by 2. Now we'll find Sx, which is area of this shaded region. Now this SXLB. Now area of this sector, which is 1 by 2 r square theta minus area of this triangle, which is 1 by 2 1 square sin x. So it will be this 1 by 2 x minus sin x. Now we need to find this limit Tx upon Sx as x tends to 0. Now this limit x tends to 0 Tx upon Sx will be this limit x tends to 0 sin cube x by 2 upon cos x by 2, and here it is x minus sin x and then into 2. Now we'll solve this question using series expansion. Now it will be this limit x tends to 0, and here will be this x by 2 whole cube upon factorial 3 into 2. Here it is 1 minus x by 2 whole square upon factorial 2, and here will be this x minus x cube upon factorial 3. Now x and x will cancel, it will be this plus, and we have this power 3 here. Now minimum power of x in the numerator is 3 and minimum power of x in the denominator is also 3. So answer to this limit is coefficient of x cube. Now coefficient of x cube in the numerator will be this 2 into and then x upon 2 whole cube. So it will be this 1 by 8, and here it will be 1 into 1 by 6, which is 6 by 4, and that is 3 by 2. So this limiting value is 3 by 2, and that is the answer to this question. Now here the question is, we need to find this limit n tends to infinite, and then it will be this 2 upon pi n plus 1 cos inverse 1 by n minus n. Now what we'll do is we'll take these terms of n together, then we can write this as limit n tends to infinite, and this is n, and it will be 2 upon pi cos inverse 1 by n minus 1 plus 2 upon pi cos inverse minus 1 by n. Now here we'll take 2 upon pi also common. So we can write this as limit n tends to infinite, and here will be 2n upon pi, and this is cos inverse 1 by n minus pi by 2, and this is 2 upon pi cos inverse 1 by n. Now pi by 2 minus cos inverse n is sin inverse 1 by n. So we can write this as limit n tends to infinite and minus sin inverse 1 by n, and this is 2 upon pi, and we'll take this n in the denominator. So it will be 1 by n plus 2 upon pi cos inverse 1 by n. Now as n tends to infinite, 1 upon n tends to 0. So this is sin inverse 0 upon 0, which is standard limit 1. So it will be this minus 2 upon pi, and here it will be this cos inverse 0, and cos inverse 0 is pi by 2. So it will be 2 upon pi into pi by 2. So answer to this limit will be minus 2 upon pi plus 1. Now here the question is, we need to find this limit x tends to pi by 2 sin x upon cos inverse greatest linear function of 1 by 4 into 3 sin x minus sin 3x, where this box represents greatest linear function. Now if we look at this 1 by 4 3 sin x, now minus sin 3x is 3 sin x minus 4 sin cube x. Now this 3 sin x will cancel, this 4 will also cancel, so this value will be simply sin cube x. So we can write this limit as limit x tends to pi by 2 sin x upon cos inverse greatest linear function of sin cube x. Now when x tends to pi by 2, sin cube x tends to 1, but it is still less than 1 because it will be 1 only at pi by 2. So within the vicinity of pi by 2, it will be less than 1. So this sin cube x, it is nearly 1 but less than 1. In that case, greatest linear function of sin cube x will be nothing but 0. So it will be this sin pi by 2 1 and then cos inverse 0, and cos inverse 0 is pi by 2. So answer to this limit will be 2 upon pi, and that's your option A. Now here the question is, we need to find limiting value of this function f(x), limit x tends to pi by 4, and it is 2 root 2 minus cos x plus sin x whole cube divided by 1 minus sin 2x. Now what we'll do is, we'll take this 2 root 2 common, then we can write limit x tends to pi by 4, it is 2 root 2, and it will be 1 minus, and this is 1 by root 2 cos x plus 1 by root 2 sin x whole cube upon 1 minus sin 2x. Now this is cos A cos B plus sin A sin B, so it will be cos A minus B. So we can write this as limit x tends to pi by 4, 2 root 2 1 minus cos pi by 4 minus x whole cube upon 1 minus sin 2x. Now what we'll do is, we'll let x as pi by 4 minus h. So it will be this limit h tends to 0, 2 root 2 1 minus cos cube h, this part it should be this cos cube, and then it will be 1 minus sin 2 into pi by 4 minus h, will be sin pi by 2 minus 2h, that will be cos 2h. Now we can write this as limit h tends to 0, and it will be this 2 root 2 1 minus cos h 1 plus cos square h plus cos h upon 1 minus cos 2h. Now for this, we'll multiply and divide everything with h square, and for this, we'll multiply and divide it with 2h square. Now this is 1 by 2. This also is 1 by 2, which will cancel. Now h square and h square will also cancel. So we'll get this limit as 2 root 2, and this is 1 plus 1 plus 1. It will be 3 divided by 4. So this value will be 3 by root 2, and that's your option D. Now we are given this function f(x), which is defined in terms of this limit n tends to infinite 1 upon 1 plus n into sine square pi x. Now we know that sine n pi is 0. So if x is an integer, then in that case sine pi x will be 0, and for all such cases value of fx will be 1. Now when x is not an integer, then in that case sine pi x, it is unequal to 0, and if it is unequal to 0, then we put this limit n tends to infinite, it will be 1 upon infinite, which is 0. So this function will take the value 0. So this function fx is such that it is 1 if x is an integer, and it is 0 if x is not an integer. Now the first one is range of f is a singleton set. No, it has two values, 1 and 0. So option A is incorrect. F is continuous on R, not possible. C is f is discontinuous for all x belongs to z. Yes, that's true. It is discontinuous for all x belongs to I. And D is f is discontinuous for some x belongs to R. So if it is single option, then I think better one is C, but then this D is also correct, because this function fx is discontinuous for some values of R, and all those values, they are integral values. Now here the question is, we need to find this limit L, which is limit n tends to infinite cos pi into under root of n square plus n. Now we'll take this n square out. We can write this as limit n tends to infinite cos pi into n, and here will be 1 plus 1 by n to the power 1 by 2. Now we'll use binomial expansion. We can write limit n tends to infinite cos n pi, and here will be this 1 plus 1 by 2n, and then it will be 1 by 2 and 1 by 2 minus 1, so it will be minus 1 by 8 n square plus higher powers of n. Now this is limit n tends to infinite cos, this is n pi plus pi by 2, and then minus pi by 8n. Now cos n pi plus theta is minus 1 to the power n into cos theta. So it will be this limit n tends to infinite. Now it will be minus 1 to the power n cos pi by 2 and plus this big notation of 1 by n. Now when n tends to infinite, this is oscillating value, minus 1 plus 1, this is cos pi by 2, and this is simply 0. Now cos 90 is 0, and 0 into oscillating value is 0. So answer to this limit is 0, and that's your option C. Now the question is, we need to solve this limit x tends to 0 greatest in a function of 1 minus e to the power x sin x upon mod x. Now since this question has both greatest integer and mod with change definition at 0, we have to use left hand limit and right hand limit. So first we'll write its left hand limit. So its left hand limit will be limit x tends to 0 negative 1 minus e to the power x sin x upon mod x. Now we let x as 0 minus h, so it will be this limit h tends to 0 positive, and it will be 1 minus e to the power minus h, and here will be this sign minus h upon mod of minus h, which we can write as we get a function of 1 minus e to the power minus h into minus sin h upon h. Now we know that if h tends to 0 positive, then e to the power minus h, it lies between 0 and 1. Then 1 minus e to the power minus h will be greater than 0 but less than 1. In the same way, we know that if h is positive, then h is nearly 0, then sin h is less than h and will be greater than 0, or we can say sin h upon h will lie between 0 and 1. And we multiply it with minus, then we can write value of sin h upon h will lie between minus 1 and 0. So one of them is positive and one of them is negative. So their product negative, and both of them, the value lie between 0 and 1. So value of this product 1 minus e to the power minus h into sin h upon h will lie between minus 1 and 0. And if this value lies between minus 1 and 0, then its greatest new function will be minus 1. So its left hand limit is minus 1. Now we'll come to its right hand limit. Now for its right hand limit, we'll write limit h tends to 0 positive, and then it will be greater function of 1 minus e to the power h, and here it will be this sin h upon h. Now in this case, e to the power h will be greater than 1. So 1 minus e to the power h will lie between minus 1 and 0, whereas sin h upon h will lie between 0 and 1. Now again this product 1 minus e to the power h into sin h upon h, it will lie between minus 1 and 0. So value of this greatest function again is minus 1. Now since left hand limit is minus 1 and right hand limit is minus 1, value of this limit is minus 1, and that's your option A. Now here the question is, we need to find the value of this limit x tends to 0 cos of sin x minus cos x upon x to the power 4. Now what we'll do is, we'll use the formula for cos c minus cos d. So it will be 2 sin c plus d by 2, and there will be sin x plus x by 2 into sin d minus c by 2. So there will be sin x minus sin x by 2. Now what we'll do is, since it is sin 0 and sin 0, we'll multiply and divide it with x plus sin x by 2 and x minus sin x by 2. We have this x to the power 4, and here will be this x square minus sin square x whole divided by 4. Now this is 1 and this is 1, and this 2 will cancel. So we'll write this as limit x tends to 0 x square minus sin square x upon 2 x to the power 4. Now we'll write this as limit x tends to 0 x plus sin x into x minus sin x upon 2x to the power 4, and we'll use series expansion of sin x. So it will be this limit x tends to 0. Now this is x plus x minus x cube upon factorial 3, and here will be this x minus x cube upon factorial 3 upon 2x to the power 4. Now here x and x will cancel, minus and minus will be this plus. So lowest power of x in the denominator is 4, and lowest power of x in the numerator is also 4. So answer to this limit is coefficient of x to the power 4. Now this is 2x, so it will be this 2 into factorial 3, which is 1 by 6, and then it will be this 2. So answer to this limit is 1 by 6, and that's your option B. Now here the question is, we are given this function fx, and it is limit m tends to infinite, limit n tends to infinite, cos to the power 2 factorial n pi x to the power m. So we have actually rearranged it. Now we are taking two cases. Case 1, if x is rational. Now if x is rational, then x is of the form some p by q, where q is an integer, and when we multiply this factorial n with pi into x, which in this case is p by q, as n tends to infinite, this n will contain q at some place. So this q and q will cancel. So basically it will be an integral multiple of pi. And if it is an integral multiple of pi, then in that case cos factorial n pi p, it will take the value either plus 1 or minus 1. So in this case, when x is rational, this fx will simply be plus or minus 1 to the power 2m, which is 1. So when x is rational, the value of fx is 1. Now if x is irrational, in that case, this cos factorial n pi p, it cannot be plus or minus 1. That means the value of cos square factorial n pi x, it will lie between 0 and 1. And if this value lies between 0 and 1, then this limit m tends to infinite, cos square factorial n pi x to the power m will be 0, because we know that a to the power infinite is 0 if a lies between 0 and 1. So if it is rational, function takes the value 1, and if it is irrational, function is going to take the value 0. Now here the question is, we need to find this limit, which is limit x tends to pi by 2 1 minus 10x by 2 upon 1 plus 10x by 2, and this is 1 minus sin x upon pi minus 2x whole cube. Now we can write this as limit x tends to pi by 2. Now this is 10 pi by 4 minus 10x by 2. So it will be this 10 pi by 4 minus x by 2. It will be 1 minus sin x upon, we'll take 2 common, so it will be this 8 and then pi by 2 minus x whole cube. Now what we'll do is, we'll let x as pi by 2 minus h. So now we can write this limit as limit h tends to 0, and this is 10 pi by 4 minus x by 2, which is pi by 4 minus h by 2. So this is 10 h by 2. Now 1 minus sin pi by 2 minus h is cos h, and it will be this 8 h cube. Now we can write this as limit h tends to 0, 10 h by 2, and this is 8. We'll take this 1h here and then 1 minus cos h upon h square. Now here we'll multiply by 2 and divide by 2. Now this is 1 and this is 1 by 2. So this limit will be 1 by 32. And that's your option C. Now here the question is, we are given this function fx, which is x plus 3 when x lies between minus 2 and 0, 4 when x is equal to 0, and 2x plus 5 when x lies between 0 and 1. Now, first question is we need to find this limit x tends to 0 negative f greatest real function of x minus 10x. Now, if we look at graph of y equals x and y equals 10x, then when x is negative, then in that case x is greater than 10x. That means x minus 10x is greater than 0. But this value, it lies between 0 and 1. Therefore, its greatest real function x minus 10x will take the value 0. So this limit will be equal to f0, and f0 is 4. That means the correct option is this option B. Now the next one is limit x tends to 0 positive f fractional part of x upon 10x. Now we know that when x is positive, then x is less than 10x, or x upon 10x, it is less than 1. Now when h lies between 0 and 1, then fractional part of h is same as h. So that means this limit, it will be simply limit x tends to 0 positive f x by 10x. Now x by 10x is actually less than 1, and if it is less than 1, it will go to this definition. So we can write this as limit x tends to 0 positive 2 times x upon 10x plus 5, which is 7. So answer to the second part is 7, and that's your option C. Now here the question is we need to solve this limit, which is limit x tends to 0, and then this summation greatest real function of r square sine inverse rx upon x, where r varies from 1 to n. Now we know that when x tends to 0 positive, sine inverse rx, it is greater than rx. So basically sine inverse rx upon rx will be greater than 1, and if we multiply r cube, then we can write r cube sine inverse rx upon rx will be greater than r cube. So this value, it is r cube plus h. So greater function of r square sine inverse rx upon x, it is equal to this summation r varies from 1 to n r cube, and it is equal to 100. Now this is n plus 1 upon 2 whole square, and this is 100. So we can write n plus 1 will be equal to 20, which is 5 into 4. That means value of n is equal to 4. So n is 4, and that is answer to this question. Now the question is find the possible value of k for which this limit is equal to 1 by 2. Now what we'll do is we'll divide everything with x cube. So we can write limit x tends to infinite 2 minus 10 inverse x upon x whole cube, and here it will be 8 upon pi cot inverse mod kx plus k square. Now will be sine 1 by x cube, and here we have x cube, which we are going to write as 1 by x cube, and here it is minus 3k, and it is equal to 1 by 2. Now we'll take this limit x tends to infinite. Now this is 2 minus, now tan inverse infinite is pi by 2 and pi by 2 upon infinite is 0. Here this is cot inverse infinite. Now cot inverse infinite is 0. So this is 0. Here sin x upon x, when 1 upon x cube tends to 0, it is 1. So it will be this k square minus 3k, that is equal to 1 by 2. So from here we can write k square minus 3k minus 4 equals 0. So it will be this k minus 4 into k plus 1 equals 0. So value of k is either minus 1 or value of k is 4. That means the possible values are minus 1 and 4. Options B and D. Now we have this case when we have assumed that this k is unequal to 0, because this expression cot inverse kx will make a difference whether k is 0 or non-zero. So we have to consider one more case considering k equals 0. Now if k is 0, we'll have cot inverse 0 and cot inverse 0 will be pi by 2. In that case, we'll have this limit x tends to infinite 2 minus 0. Now this is 8 upon pi into pi by 2. There will be 4 plus k square minus 3k, and if k is 0, this value is again going to be 1 by 2. So that means one more value of k is possible. So there are 3 values possible for k, which are 0, minus 1 and plus 4. Question number 11, we are given the sequence which is fn x equals x to the power n cos 2 pi nx when x belongs to minus 1 and plus 1. And we need to find this limit n tends to infinite fnx. Now if we consider this first case, when the value of x is 1, we can write fn1 as 1 into cos 2n pi, and cos 2n pi is 1. So in this case, limit n tends to infinite fnx will be simply 1. So for x equal to 1, this limit exists. Now we'll consider the second case when the value of x is minus 1. Now we'll have fn minus 1 and it'll be minus 1 to the power n cos 2n pi into minus 1, which is minus 1 to the power n. Now if we take this limit n tends to infinite fnx, then in that case this value, it can be either minus 1 or plus 1. That is, we'll get an oscillating value. So in this case, this limit, it does not exist. And finally, when x lies between minus 1 and plus 1, in that case, this mod xn cos 2n pi x will be mod of x to the power n into mod of cos 2n pi x. And if we take this limit n tends to infinite, now this is oscillating value from 0 to 1, and since mod x, it lies between 0 and 1, this is 0. Now 0 into anything finite is simply 0. In this case also, this limit exists. So this limit will exist if and only if x belongs to the interval where minus 1 is not included and 1 is included, and that's your option D.